We are integrating by parts these functions. We have to integrate by parts mainly when we have two functions completely different. So here we have a polynomial and an exponential. Here we have a polynomial and a trigonometric ratio, and again the same. So two things that are like not very related. We have to choose an u. So I'm going to do the first one. We can choose either. If we know how to integrate and derivate both, it doesn't matter, but usually it's better if we use as u the one that when we derivate it becomes smaller or simpler, like polynomials. So I'm going to pick u as x, and then I'm going to choose dv dx, the other function, which is e to the power of x. We are using the formula. Yeah, the formula is in the formula booklet. So we have u, which is this one, dv dx, which is this one, dx. And now we need v and the u. So what we are going to do with the u is derivate. So du dx is 1, just derivating, and we are going to find v integrating, which is e to the power of x, or yeah. So we have done our work. Now we substitute in the formula. This one is uv, so u is x, v is e to the power of x, minus integral of v, which is e to the power of x, du dx, which is 1, and then dx. And this is simple to integrate. So ex e to the power of x plus c. You can leave like this, or if you prefer, you can factorize. It looks a bit nicer, but it doesn't matter. It's just being picky. Yeah. The second one, I have 4x sine x. So b is integral of 4x sine x. And again, I'm going to get 4x as u, so it becomes smaller when I derivate. And the other function is going to be my dv by dx, so sine x. I'm going to derivate this one to have du dx, which is 4, and I'm going to integrate this one to have b. So v is cos minus cos x. And I substitute, yeah? I have u v is going to be 4x minus cos, so minus 4x cos x, minus integral of v. V is negative, so this minus is becoming plus, plus cos x, and dv, du dx is 4. I can write the 4 outside if I want, and then dx. So 4 dx, and I integrate that easily. So this I'm working out for that. So I have minus 4x cos x plus 4 sine x plus c. Yeah. And the last one, c is x cos 2x. So c is x cos 2x dx. I'm going to make this smaller or move it up a bit. I'm going to get u is x, and dv dx is cos 2x, which means du dx is going to be 1, and v is going to be the integral of cos 2x, which is sine 2x divided by 2, because when I derivate the sine 2x, I have a 2 that I don't want, and I substitute. So I have u v is going to be x sine 2x divided by 2. I'm going to write the divided by 2 here, minus integral of v. I can write them 1/2 at the front, and then I have sine 2x. Du dv is 1, so just dx, and easily I integrate that. I don't have the space. So I have x half sine 2x. Integral of sine of 2x is going to be minus cos 2x. With this minus is plus. I have 1/2, and then cos 2x divided by 2. So I can put the two together, the two together. So I have 1/4 really here plus c. Yeah, and remember, integral of sine is minus cos. So this plus becomes from that minus cos and this minus. Yeah, and that's it.